Welcome to Let's Get Mathy. Today we're going to discuss how to write domain and range from a graph. We're going to build off of inequalities to represent the domain and range of a function from its graph. So from prior knowledge here, you should recall that the domain is the set of input values, or your x-axis. The range is the set of dependent values, also the y-axis. So we're going to be specifically looking at graphs. This first graph I chose specifically because of its ambiguity here at the end. Is this graph going on forever or is it ending? So I'm going to make the decision for us and say that this graph is terminating right here on the x-axis at -5 and over here at the other side at +5. So the domain, as we can see, goes from here in the graph to here. So from -5 to +5. I realize my line's off a little bit there. So the real focus is, okay, how do we represent this with an inequality? Well, what we're saying is that the x values are in between these two values. So a lot of times you can just kind of set up your sort of endpoints in a sense. And we know x is in between them. Well, we know x is larger than -5. So with inequalities, I know that they're a little confusing, right? Because they can be read in either direction. So one way that I found is helpful for students is if you look at an inequality, you can see you have two endpoints on this side and one endpoint here. 2 is bigger than 1, so now we know that x is larger than -5. And similarly, x is less than or equal to 5. So that is the domain values for that graph. Moving over to the range value, or your y-axis, students sometimes find this side a little bit trickier than the domain. So you want to orient yourself now on this axis here. So you're looking now for your high points, low points. So if we look here, we can see a distinct low point. This is the lowest value right here. And then we can just see a distinct high point over here. So with your range, you're looking for your low values to your high values. So coming along this axis here, again, we're looking at the y-axis. Apologize that I'm off a little bit there. You can see that we're at a 0 on our y-axis. And coming along here, we are at 4. Some of you might be thinking, is it really 4? Is it a little bit below 4? I'm going to make the executive decision here and say it's going to 4. So the low value on the y-axis is 0. The high value is 4. And again, the range is the set of all independent values. So we're going to say y, which is the axis that refers to your dependent values. So y is larger than or greater than or equal to 0, and also less than or equal. So you might be looking at this graph saying, whoa, Miss Smiley, this looks the exact same. Well, it is the exact same. As I told you guys, I picked this graph to cover because I found it to be a little bit unclear in its delivery. So now I'm going to look at this graph with you in terms of what if these values actually went on forever, right? So it doesn't terminate at -5 over here and doesn't terminate at 5. Well, we can see here that this graph is going on forever in the x direction as well as the y direction in the upward notation, upward trajectory. There's nothing down here. So if we look at this, when we have arrows, arrows are going to signify the infinity symbols at some point in your domain and range, maybe a combination of both, maybe just one. So again, arrows, you are going to use infinity symbols to represent that idea. So we can see here that the domain is going from -infinity over here to +infinity over here. And again, we are just specifically focusing on inequality notation. There are other ways to show domain and range, and you'll learn those in future classes. So your domain is negative infinity is less than x, and x is less than positive infinity. Your range, again, we want to think about the low point to the high point. Well, it's not going to negative infinity, right? It's not going down here. So it's still beginning at 0, but it is going on forever because of these arrows are going up. So we can see here that y is simply greater than or equal to 0. Sometimes students like to still write it as a compound notation. So 0 is less than or equal to y, which is less than infinity. So we can see on this graph, it's similar but different. I apologize that the arrow is cut off, but it looks the same on this side. What we have here is a quadratic function. So the domain for any quadratic function, any linear function, any exponential function, right? If you can identify them as one of those 3 parent functions from your Algebra 1 course, you will then easily be able to recognize the domain. The domain is going to be all real numbers, and we represent that again by negative infinity to positive infinity. So we're going to talk quite a bit about parent functions coming, and it is going to save you some work in the long run if you can identify when you're looking at a graph what parent function is, because if it's one of those 3, the domain is always going to be this. Now that does apply to some other parent functions that we didn't cover in depth in Algebra 1. So this concept does apply to other things. It's not limited to that, but I'm just using what I know you guys to have learned in Algebra 1. Now, again, with your range, you're going to think about your low point to your high point. Well, because this graph is reflected, the low point is going down to negative infinity on the y-axis, and its maximum or highest value is at 3. So it's a little bit different than the last one, but then again, similar. So the range is from negative infinity, which is less than y, which is less than, does it include 3? Yes, it does. So it also includes 3. So we have our domain and our range. There is also another way you could write this by just eliminating this part. It is, in a sense, implied, and y is less than or equal to 3. So I am going to leave you here with a little your try. On the next slide, you will see here, this graph, again, is a little bit similar, yet slightly different to the others. So give it a try and we will discuss your answers. Well, hope you've enjoyed getting mathy with me today, and I look forward to seeing what your solutions are.